Hello, this is an ad hoc screencast where I'm going to go over some analysis on an intracranial recording, and this just speaks to the general concept of using trends for looking at the more zoomed out view over a longer period of time, using the high frequency display to select channels of interest, and then actually going into Insight 2 to do some additional analysis that really is just a demonstration that if you're doing something over short time frames, then Insight 2, available from the Tools menu, is designed to do all sorts of analysis over shorter time frames, and Persist, the main interface, really over longer time frames, although you can show the trends in both. This is Michael Guest, VP of Research and Clinical Applications for Persist Development. Let's get started. This is an intracranial recording. It's already been trended. And there are instructions and examples on how to trend intracranial EEG, but this is a short recording, and we have a number of trend panels. I just dropped the time frame to 15 minutes for this, and you can see we have some different trends set up. We have the FFT spectrogram. We happen to have spike rates showing up at the top. We have amplitude integrated EEG, which is very interesting for intracranial for a number of reasons. Unexpectedly kind of handy. A rhythmicity spectrogram, which is helpful for looking for evolving rhythmic changes. This one's pretty straightforward. You have these series of seizures, which are predominantly spikes in the waveforms. And if we go to the versus baseline FFT, this is showing statistical changes. And let me go ahead and just set this to show the range of 0 to 50 hertz. These are pretty dramatic changes where you have, a major increase in amplitude during the seizure and then a decrease in amplitude following the seizure, this electrodecremental stuff. But if you're going to do trends on channels looking at even much higher frequencies, which you can do, and you want to get around that issue where you tend to have a lot of power in the lower frequencies and very low amplitude at higher frequencies, because these are showing z-scores, normalized z-scores, based on an empirical null that was marked here. I just happened to put it there. Then you get around that problem of having a lot of bloom in the delta range, and you miss out seeing what's happening in the beta, gamma, and so forth ranges. So that is just a quick view of that. And what we're going to do is really just use this to find the place of interest, and it's pretty easy to spot. These seizures are happening here. So without getting too far into the trends, because you can trend intracranial, these happen to be built by Hardware Group using montages that were created semi-automatically by the intracranial montage creator to create channel lists of hardware groups. So you don't end up with 200 trends, not very helpful. You end up with a subset of trends based on anatomically related channels. Skipping past that, we're just going to go to the EEG page because we're at a place of interest. And let's say I want to look at high frequency. So this will be our first zoom in, as it were, where we're going to look at a high frequency display. And that's to find out, okay, we have channels with spikes. Let's see if there's high frequency activity in those channels, and if it shows up on all the channels with spikes or only some of them. So that's kind of a helpful question to ask. And to do that, the first thing we notice here is we're set to 70 microvolts. We can even go to 100. We have 0.16 seconds. This is actually time constant. You can set that to frequency under the preferences, 70 hertz. So 1 to 70 hertz Berger band EEG. And let's do some high frequency display stuff. So to do that, we'll go to Tools, and I'm going to do create high frequency display. And let's say I'm going to go 30 to 200 hertz. My Berger band is at 100. I'm going to set this to 7 microvolts, and I'm just going to click OK and see what we get. I've already created a montage. It's going to override it. It creates a montage, which this looks kind of crowded together. Can't really see what's going on. So let's do the first thing, which is to select the All button, and I'm going to move this down to 24 channels so we can get a closer view, maybe even 16 channels. And now we get a vertical scroll bar on the right, and I can page up and down, and I can see that I've got spikes superimposed with the high frequency display data, and the green is the 30 to 200 hertz. I can change the frequencies if I want from the drop downs, not a problem here. and 7 microvolts. And the overlap is selected, so it's laying that one on top of the other. If I turn off the overlap button here, I've got high frequency and the Burger band high frequency. And you can see that some of these channels have spikes, and some of those, which appear to have spikes, don't necessarily have the phase-locked high gamma here. So we're going to move past that without digging in too far. Well, actually, let's dig in a little further. So I'm going to go ahead and change the time frame. We're at 10 seconds here. Let's go to 3 or 4 seconds. 3 is good. And now I can maneuver using the single arrows to go forward and back. And I can use these up and down arrows, again, to pick channels of interest and see where I want to go. Let's move a little further into this. And this is a good spot. So with these channels set to 16, I can overlap these and get a pretty good view of how these line up. So there's high frequency in multiple channels. You can see with these spike discharges, these really just line up very nicely. And I can get a measurement, quick measurement, just by using the Quick Stats tool. So let's do that. I'm going to go to Tools and Quick Stats. And if I drag a box around a waveform, here I can see the frequency and the amplitude of what I dragged the box around. And if I want to be even more clear about that, I can go ahead and turn off the overlap. Again, select that Tools button, and I can do the Quick Stats tool, drag a box around something of interest, and get a frequency, and that's saying it's 65 hertz. Okay. And you can zoom in even further to look. So that's one tool. If I hold down the Control key, by the way, I can do multiple iterations of this, if that was of interest. And that just gives me a zero crossing frequency and amplitude. So that's one way to do measurements of this. But let's say I want to go even further and do measurements of this. Let's go ahead and pick a different montage. So what happens is this high frequency display tool creates a montage that has both Burger band and high frequency traces, and I can overlap them and use that to page up and down using this vertical scroll bar, and I can see which ones are more of interest. And actually, as I page down, maybe I'm a little less interested in that and more interested in these ITG channels. So let's go down a little further, and I want to have just the montage with the ITG. I could switch back to my bipolar montage and delete the channels that are not in the ITG and save that, which I already have done. And this is a feature in P14D and later where you can have montage categories. This makes it easier to navigate, so you don't have a gigantic list of montages. You can categorize them. And they all disappeared. What happened? Well, I'm still showing only 16 channels. I'm going to go back to all. And now I've got just my ITD channels. And let's see which ones are of interest. So I'm going to go to Tools, and I'm going to create that high frequency display again. And this time it's going to create it on this H2 ITG channel set. Select OK. I've already done this. And so now I've got this display where I can see which channels might be of most interest here. And again, just for the sake of demonstration, I'm going through this fairly quickly. But let's just say for the sake of demonstration, I'm more interested in looking at ITG9 and ITG15 for those. And I want to do something a little more detailed with this. So to do that, I'm going to launch Insight 2, and that's from the Tools menu. And this gives you something where you can do frequency analysis or other analysis beyond just dragging a box around something and getting quick stats. And I've already launched Insight 2, so that's sitting back here. And so once I launch Insight 2, it goes to that same page of the EEG that I was just on. It hasn't set the same time frame and so forth. I'm still at 10 seconds, so I'm going to reduce that. And I can still select that high frequency display from the montage drop down. So Insight 2 and Persist, it's the same program. The difference is Insight 2 has a lot more buttons that facilitate doing more detailed analysis. That may not fall into the realm of day-to-day clinical work. This is where the big tool set is. Same program, which is why they're synced and so forth. So now we can see that here's my ITG9 and my ITG15 channels, and I can go a little bit further. These arrows really jump between events and pages, so if I go over the scroll bar This may be a Windows 11 thing where you have something fade in and out like that. It is living in Windows 11 at the moment. You can run this on Windows 10 as well. Hence the rounded corners on the program. That's a Windows 11 thing. All right. Now, I want to narrow this down to just the two channels of interest. So to do that, I can leave this in overlap, or I can intersperse it. So the way this is formatted is I've got the high frequency, low frequency, high frequency, low frequency channels. And so if I wanted ITG9, then I could just highlight this range of channels and I can hide these. So I'm going to right click on this and I'm going to select hide selected. Okay, I've done that. Now I want to have ITG15. So I'm going to go down to this one through 14, highlight all these, right click on one of these box channels, hide selected. And there will be a rationale for doing this in a minute. And let's go ahead and hide these two. So now I've got just my ITG9 and my ITG15 channels. And what I'm showing here in the non-overlapped, so that's the overlapped view, is this is the high frequency, which is at 7 microvolts using a low cut filter of 80 hertz. Let's actually change that to 30. That's the default value, and let's change this to 200. So you can change these values based on what you want to look at. And so I'm going to do some FFT graph on these. So I'm bringing this out a little further. And this one I'm still going to leave at 1 to 70 hertz on that. So how can I do some more detailed frequency analysis on this? I can right click on this, and granted, you know, we're going to look at a whole page. So you can select ranges, you can select smaller ranges of time and so forth, but let's say for the sake of argument, we're just going to do the page of EEG and look at the distribution of high frequencies. So I can insert a vertical adornment and do frequency domain analysis, and I get an FFT graph, but it's only 0 to 30 hertz. So now we start right clicking and making some changes. So here I'm going to do right click and go to properties. I'm going to do binned analysis, and that'll make sense in a moment because I'm going to mark a range to get a table of values from this. Data ranges, I'm just going to leave it at the EEG page for now, but you can do events as ranges. You can mark comments or events, mark a comment with a duration and persist, and take those comments in aggregate, whichever ones you select as ranges, and do FFT or any other analysis in this on those ranges that you've selected. And by creating comments with a duration, it saves that in the recording so that you close it, you come back the next day, you want to do the same analysis, you can pick those same marked ranges. But I'm just going to do the current page, not to get into that part of it. I'm just going to say, well, just do it on the visible page. And the spectrum, I'm going to set this 30 to 200. So I can change the frequency ranges here. And now I'm going to click OK. So naturally, these look different because, you know, this has a 1 to 70 hertz filter and this has a 30 to 200 hertz filter. So, but it's nice to see both because it's the reality check. We're not just looking at the Burger Band EEG. We're looking at high frequency, so we can actually see what we're going to make a measurement on. So now I've got this. These are the FFT graphs, 30 to 200 hertz. Let's insert a range because I can define the frequency ranges of interest. Let's say I was just interested in this. Or let's say I wanted to just do the whole range. So I could drag these carets at the top, and I can drag them all the way out to 200 hertz. I got 29.64, 199. You can actually go to properties here, right click, and there's the range I marked. So I can select edit and set this 30 to 200. And I'm going to add that. So there's the range, 30 to 200. Okay. So I've defined this range. Now I want to get the values from this. I'm going to right click, insert vertical adornment, and pop in a table here. And I'm showing the average amp, which is the sum of the amplitudes underneath the curve, rather the sum amp is the integrated, and the average is just the average of all the amplitudes under there. So I'm going to select properties. So there it is, the average amp or power within the bin. The bin is the whole thing. Sum is the integrated amplitude or power within the bin. I'm going to add peak and mean frequency here too, show everything. So now I've got these values. And I can right click and I can copy that text to a clipboard and paste it into Excel or any other application. So now I can page forward, and let's say get values from any place along the way, but I can go, let's say, to seizure offset, right? And see what happens in the high frequency in these channels at the offset of the seizure or at any time. This graph updates every time I page forward. So there you have it. There's the rather quick overview of going from high-level view of the EEG and over that time period, and doing that again in persist with trends, so I can go navigate at a higher scale, and then going to tools and insight 2. That's where we can go in and do further analysis. Now, I don't want to recreate this every single time. That's a lot of work. So I can save what I've done as far as configuring that tool by going to montage, save adornment montage, and I'm just going to call this FFT FDA, frequency domain analysis, and now it's saved. And so I can select this from this drop-down list, or select NA, and it's gone. So that makes it easy to do. Notice this went 0 to 30 again. That's a default, so go to properties. There's one thing you'd have to set each time, which is frequency range of interest. And there we go. So now it's back to 30 to 200 hertz with that range. That is a rather quick way of going through it, but I wanted to accompany this with a document that I put together showing the steps. This isn't the only analysis you can do. Of course, you've got lots of other analysis tools that you can apply to this, and or even under it. It's interesting to see, for instance, what a continuous wavelet transform looks like when applied to the EEG. Of course, there you have accuracy in time and frequency doing wavelet transforms. So just an interesting visual to wrap up with. Again, this is Michael Guess, VP of Research and Clinical Applications for Persist Development Corporation. Thanks so much.